This is lesson 8.2, the Pythagorean theorem and its converse, starting on page 551. For number 1, find x. So x is a leg. The Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. So we would substitute in the leg that we know, the legs making up the right angle that is. So we have 5 squared plus x squared equals hypotenuse is 13. So the hypotenuse is the side across from the right angle. So we would get 25 plus x squared is equal to 169. We would subtract 25 from both sides and get x squared is equal to 144, and take the square root of 144, so x is equal to, and we only want the positive square root, so x is equal to 12. For number 3, we want to find the leg. So Pythagorean theorem says leg squared plus leg squared is equal to hypotenuse squared. So x squared plus 16 is equal to 256. So if we subtract 16, we get 240. Can be broken down, so 240 can be broken down to 24 times 10, which is 4 times 6, so 2 times 2, and 2 times 3, and 2 times 5. So x squared is equal to the square root of 1, 2, 3, so 2 to the 4th, and times 3 times 5, not 15, getting ahead of myself there. Okay, and we have a pair of 2's here, a pair of 2's there, so we can take out for the first pair of 2's, for the second pair of 2's, and then we're going to multiply 3 and 5 back together, so that's the square root of 15. So this is equal to 4 square root of 15, or the square root of 240 as a decimal is approximately 15.5. On number 5, the mainsail of a boat is shown. What is the length in feet of Ln? So Ln being the hypotenuse, opposite from the right angle. So that's our C value. So we would take 60 squared, A squared plus B squared, 45 squared, and set that equal to C squared, which is X. So square 16, you get 3600. 45 squared is 2025. And they have a sum of 5,625. So take the square root of that, and x is equal to 75, which is answer D. For number 7, determine whether each set of numbers can be the measures of the sides of a triangle, and if so, classify the triangle as acute, obtuse, or right, and justify your answer. So the first thing that we want to check for, the sum of two sides must be greater than the third side. So 16 plus 18 is greater than 26. 18 plus 26 is greater than 16. And 16 plus 26 is greater than 18. So these do represent the side lengths of a triangle. The next thing we want to check for is take the longest side and square that. So 26 squared gives us 676. And then take the other two sides and square those. So, and add them together. So that would be equal to 256 plus 324. And if we add those two together, let's see, we would have 580. And then we want to compare our longest side squared to the sum of the other two sides squared. So 676 is greater than 580. So since the longest side squared is greater than the sum of the other two squares, then it must be an obtuse triangle. On number 9, we apply the Pythagorean theorem. We are looking for the hypotenuse, which is c. So we have a squared plus b squared is equal to c squared. So we get 144 plus 256 is equal to x squared. And they have a sum of 400. Then we would take the square root of both sides, and x is equal to 20. On number 11, to find x, we use the Pythagorean theorem, and this time we're looking for a leg, so you can call that either a or b. So I have a squared plus b squared is equal to c squared, and x squared plus 4 is equal to 25. So x squared is equal to 21, and x is equal to the square root of 21, and the prime factorization would be 3 times 7, so there are no double factors. There's no pair of factors that we'd be able to cancel out and take out of the radical. So we would either leave it as the square root of 21, or we can use a calculator and get an approximation of 4.6. For number 13, we're looking for the hypotenuse, so we're looking for c. So we have 1/5 squared plus 3/5 squared is equal to x squared. So square 1/5, and that would be 1 over 25. Square 3/5, and 3 squared is 9 over 25. And so if we add these two fractions, we would get 10 over 25. And then we want to take the square root. So the square root of 10 does not simplify, but the square root of 25 is 5. So x is the square root of 10 over 5, which we can approximate. So the square root of 10 divided by 5 is approximately 0.6. On number 15, it says use a Pythagorean triple to find x. We'll just use the Pythagorean theorem. So we have 16 squared plus 30 squared is equal to x squared, x being the hypotenuse. So that would be 256, and that would be 900. So adding those two together, we get 1,156. So if we take the square root of that, we get 34. And it is a Pythagorean triple because all three sides are whole number lengths. So 16, 30, 34. And that would actually be, if we divide each of those by 2, it would be in the form of an 8, 15, 17 right triangle. On number 17, we would have our leg squared plus our other leg squared equals hypotenuse squared. 24 squared is 576. 74 squared is 5,476. And if I take the difference of those two numbers, I get 4,900, and the square root of that is 70. For number 19, the support for a basketball goal forms a right triangle as shown. What is the length x of the horizontal portion of the support? So we have our right triangle. We are looking for a leg. So that's leg squared plus leg squared equals hypotenuse squared. And I'm just going to convert this into an improper fraction. And this as well. So when I square those two, I would get 9 over 4. And these two, 100 over 9. And my common denominator being 36. So I multiply these both by 4. And these both by 9. So my difference there would be 319. So x is equal to the square root of 319 over the square root of 36, which is the square root of 319 over 6. And the square root of 319 divided by 6 is approximately 2.98 feet. For number 21, determine whether each set of numbers can be the measures of the sides of a triangle. If so, classify the triangle as acute, obtuse, or right. Justify your answer. So it'll only be a triangle if the sum of the two shorter sides is greater than the longer side. And 7 plus 15 is in fact greater than 21. So it is a triangle. And to figure out what type of triangle, we want to take our longest side and then see if that's equal to, less than, or greater than the shorter two sides squared and added together. So 21 squared, we have 441, and we'll see if that's equal to 49 plus 225, and the sum there is 274. And 441 is obviously greater than 274, so it is obtuse. So on 23, let's check to see if it's a triangle. The sum of the shorter two lengths, 4.5 plus 20, is 24.5, which is greater than the longest side, 20.5. So it is a triangle. And now we'll determine what type. So take your longest side and square that, and take the sum of the shorter two sides squared. So if we square these three numbers, we would get 420.25 20.25 and 400. And so if we add the two numbers on the right, we find that the two values are equal. So if the longest side squared is equal to the sum of the shorter two lengths squared and added together, then it is a right triangle. First off, is this a triangle? So 4.2 plus 6.4 would be 10.6, which is greater than 7.6. So it is a triangle. Take the longer or longest of the three sides and square that. And then take the shorter two lengths, square them, and add them together. So if I square these three numbers, I would have 57.76, 17.64, and 40.96. So 17.64 and 40.96 add up to 58.6. So 57.76 is less than 58.6. So if the longer side squared is less than the sum, then it is acute. On number 27, to find x, we have a right triangle. We're looking for the hypotenuse. So we would take a squared plus b squared equals c squared, or if you're able to recognize a Pythagorean triple, you can use that as well. So this is a multiple of a 3, 4, 5 triangle. Since 9 is 3 times 3, 12 is 4 times 3, then x will be 5 times 3. So x is 15. On 29, we're looking for x, which is a leg of this right triangle with a hypotenuse of 14, and the other leg is 10. So x squared plus 10 squared is equal to 14 squared. So we have x squared plus 100 is equal to 196. So subtract 100 and you get 96. Take the square root of that, and 96 prime factorization would be 2 times 48, which is 2 times 24, 2 times 12, 2 times 6, and 2 times 3. So x is equal to the square root of 1, 2, 3, 4, 5, 2 to the 5th, times 3. So for every pair of the same number, you can take one of those out. So I have 2 2's here. So for this pair, I can take a 2 out of the radical. I have another pair of 2's, so I can take out another 2. And I don't have another pair of 2's or a pair of 3's, so I'm going to multiply those back together. So 2 times 3 is 6. So we end up with 4 square root of 6. And a decimal approximation for that, 4 times the square root of 6 is 9.8. For 39, we want to find the perimeter and area of the figure. So the perimeter, we would just add up the three sides, 13 plus 13 plus 10 would be 36. To find the area of a triangle is half of its base times its height. So we have to figure out what the height is. So for the right triangle on the right, half of 10, this would be 5. So I have 5 squared plus h squared is equal to 13 squared. So subtract 25 from 169 and you get 144. Take the square root of that, and h is 12. So my area is equal to half of the entire base, which is 10, times the height, which is 12. So I'd have half of 10, which is 5 times 12, which is 60. For perimeter, we would want units, and for area, square units. For number 41, the sides of a triangle have lengths x, x plus 5, and 25. If the length of the longest side is 25, what value of x makes the triangle a right triangle? So if it's a right triangle, then x squared plus x plus 5 squared is equal to 25 squared. So I have x squared plus, so I'm taking x plus 5 times x plus 5, so this is a perfect square trinomial. So square the first term, multiply the two terms together and double it, so we get 5x times 2 is 10x, and square the second term. Since we have a quadratic, we want to move everything over to one side to get it into standard form. So subtract 625 from 25, so that would be minus 600. We can simplify by dividing all terms by 2. And then substitute these values into the quadratic formula. So a is 1, b is 5, and c is negative 300. So we want the opposite of b, plus or minus the square root of b squared, which would be 25, minus 4 times a, so 4 times 1, times c, all over 2 times a, 2 times 1. So if we simplify this, we'd have 25 plus 1200, so negative 5 plus or minus, and we would have the square root of 1225, which is 35, over 2, and since we're talking about a length, we only want the positive answer, so negative 5 plus 35 would be 30, divided by 2 is 15. On 43, the screen aspect ratio, or the ratio of width to length of a high definition television, is 16 to 9. So we have width to length, 16 to 9. The size of a television is given by the diagonal distance across the screen. If an HD TV is 41 inches wide what is its screen size? So what we can do here is, first of all, we have the width, which is 41, and since this is in a 16:9 ratio, we have to find the length. So 9 is to 16 as length is to 41. So if we cross multiply, we get 16 times our length is equal to 369, which we divide by 16 and we get approximately 23. So our length is approximately 23 inches. From here, we want to find its screen size, so we want to find the diagonal here, which would be the hypotenuse of our right triangle with legs 23 and 41. So 23 squared plus 41 squared is equal to c squared. So that would be 1681 plus 529, which is 2,210. And taking the square root, we get approximately 47 inches. On number 45, we would use the Pythagorean theorem, so our leg squared, which is x minus 4 squared, plus our other leg, 8 squared, is equal to our hypotenuse squared. So we have a binomial squared, so we'll get a perfect square trinomial, which would be the first term squared, then the two terms multiplied together and doubled. So negative 4x times 2 is negative 8x. And then the second term squared, so plus 16. 8 squared is 64 equals x squared. So I can get rid of my x squareds on both sides. And I can move 8x over to the other side. And 16 and 64 is 80. So divide by 8, and x is 10. For number 47, let's take our first leg squared plus our second leg squared and set it equal to our hypotenuse squared. So we have x squared. The square root of 2 squared is just 2. And to square this binomial, square the first term. Multiply the two terms together, so x, and then double it. So plus 2x. And square the second term. We have x squared on both sides, so we can get rid of that. So I have 2x. If I subtract 1 from both sides, is equal to 1. And divide by 2, and x is equal to 1/2.